Yeah, thank you everyone for joining us. Joined here by Prakash from HashiCorp, who's going to give us some awesome Terraform Cloud coverage. Yeah, Prakash, please take it away.
Thank you, Matt. Excited to be here to do this webinar with you. So I'm going to start with giving you a quick overview of well, the agenda right now is we're going to look at the cloud overview, high level. Many people already know about Terraform. We're going to talk a little bit about Terraform Cloud, some IaC infrastructure as code security challenges and what it entails. Then the exciting part is the integration between Terraform Cloud and Bridgecrew, how that's done. And Matt's going to do a demo. I'm going to quickly go over Terraform Cloud and Terraform in general so that we get to the meat of things.
Absolutely.
Next slide.
And then, yeah, before we jump into that, let's quickly remind everyone who we are, who we're talking about today. Obviously, we've got HashiCorp, and everyone probably knows those guys. So Bridgecrew and HashiCorp, we've got some really cool demos, as Prakash has just kind of highlighted, some really cool integrations to show you, which should really help productivity and kind of help your developers, help your security teams work quicker together, work faster together, reduce any kind of manual security work they were doing. Yeah, through some really cool technologies on both sides. So obviously I'm here today from Bridgecrew. I'm a developer advocate with Bridgecrew. And Bridgecrew, really in a nutshell, is just designed with the sole mission of trying to automate and improve the productivity of implementing DevSecOps. So we provide code to cloud coverage. We allow you to scan security scan code right from its inception, right when it's kind of pre-deployed Terraform infrastructure as code security, right through to kind of catching drifts and changes to that infrastructure as code or to those cloud resources once they're deployed into the cloud. So as you can imagine, we kind of plug in at every point in the developer's lifecycle we can, just to make sure that we are going to catch those issues early and give you a really easy time to fix, and also kind of provide that like virtual security team for smaller dev teams to kind of try and inject that security information into the DevOps lifecycle. I'll hand back over to you, Prakash.
Yeah, thank you. We can move to the next one. So, so before when people start their cloud journey, they start out with the UI and then they click, try to provision. And it's really cool, right? What used to take weeks, now you can provision a server, a network, everything in a couple of minutes. Then you realize you need to do your dev and your test, your prod, you're trying to recreate the same things, and you know that the clicking doesn't work. Then you try automating using CLI, use some kind of scripting language, Python, bash scripts, and that takes you for a while. Then you realize that that doesn't scale well. When you move to the cloud, things are very complex. You have hundreds of resources, and then you realize that something like Terraform can benefit. The beauty of Terraform is we call it code as documentation. So what you're writing out on the right-hand side is what Terraform code looks like for those of you who are new. And looking at it quickly, you can tell that, hey, that is what we're trying to provision. We're trying to provision a Google Cloud instance. The name is server. The mission type is G1 small. It's very easy to understand, and it's repeatable. So you put it in the code, you put it in your Git repository, and then that's how you do that. So Terraform does infrastructure as code. It's one of the most popularly used IaC languages. And it not only covers all the major clouds, it also covers things like your Cisco router, your firewalls, your load balancers, no matter what you have. So, so that's the fundamental benefit of Terraform. And it also provides you things like gives you visibility into what is being provisioned. It tells you what it's going to do, and it lets you collaborate with your teammates. It's not just one person. You're going to have a team of 5, 10, 20, hundreds of engineers who are working on it together, collaborating, and it provides you a way to work together. Next slide.
You got it?
Yeah. So Terraform is open source, and most people who start working with open source will download the OSS code on their laptops, and you can quickly start being productive with Terraform in a couple of minutes, right? You write a piece of code, you can do a plan, you can do an apply, and boom, you have your infrastructure provision in all these different clouds and infrastructure platforms. What happens is, how do you scale? There are some challenges that happen from one person to 2 to 3 to 10 people, and open source is kind of the core product that we have. It's Terraform open source is a CLI. It runs on your laptop, but it brings some challenges. One is, how do you manage the state? Terraform is state. Every time you provision something, it generates a state file, and how well you can manage that. And also your provisioning from your laptop or your machine. So now if you have 5 different people doing it, they're all doing individually, and they can step on each other's toes. So with Terraform Cloud, we are bringing in a new way of doing things. The workflow is slightly different. Next slide, Matt. So we are moving from the left, which is Terraform OSS, to Terraform Cloud, where you have a central platform that you can still use your CLI if you like, but you don't have to use it. But it provides you a central layer, a shared service that all the different developers and DevOps teams can share, and they can collaborate on to provision infrastructure. So this is the left is the OSS, where it's 1 or 2 people working. And you're working, with your public module registry, where you have your templates for your infrastructure. To the right-hand side, where you can have your own for your organization, you can have your own your private module registry, and this is for when you want to scale your organization. Next slide, Matt. So Terraform Cloud provides you the following. It's very simple to use. It's actually the basic thing is basic tier is free. We have advanced paid versions, but you can get started today for free. You create a Terraform Cloud account using your either through GitHub or your login ID password. You can put all your code in VCS like GitHub or GitLab, Bitbucket, and you can connect it in a matter of minutes. Then you can start provisioning from the UI. It solves a number of things like state management, where to keep state, and it keeps a version of the state, and it basically solves a problem of collaboration. It has a number of features like single sign-on, for example, audit and other things that bigger organizations need, but it basically solves the problem of how do many people collaborate on infrastructure as code. Next one, these are a highlight of some of the automation features. Obviously, it does infrastructure as code. You can directly connect to VCS repos, GitHub, Bitbucket, we support a few. So you don't have to write anything to connect your code to your Terraform infrastructure. It does it for you. Remote operations basically mean that you don't have to run Terraform from your local machine. You can run it from a centralized machine, and what it does is it secures it. So you don't have to have your variables stored on your laptop or your secrets file. It's all in a centralized, an admin could set it up and people can use it. And it also provides an API if you want to automate it, if you want to integrate it with CI/CD. You can write your own front end to provision. It helps you do that. And then the collaboration features are state management. It provides a history of state. You can lock your state file. So if you don't want somebody to make any changes to a certain piece of infrastructure, you can mark it as locked. You can have an approval workflow where somebody can kick off a run and somebody else, the admin, can go and approve that. a single place of glass for all your infrastructure. You can look at all the different workspaces or the infrastructure that's been provisioned. And of course, the private module registry. So these are all the different kind of features that Terraform Cloud provides that are very essential, we think, for an organization to scale their IaC journey. Next. So one of the main things that we're going to talk about today is, yes, now you have infrastructure as code, you have Terraform, and you want to do things fast. You want to give developers the ability to provision really provision infrastructure, and they're going to do that. But as an organization, you want to make sure you put the guardrails to protect yourself. There's a story of a company who provided the developers the ability to provision S3 buckets. And what happened was one person made a mistake and they left it public. And what happened was a lot of the documents that were stored in the S3 bucket got compromised. So how do you make sure that while at the same time you want to give people the power to provision infrastructure, you also protect yourself from making mistakes? And this is where we have the governance module that's built into Terraform Cloud. And it provides you a framework to write policy as code, and you can put the policies in your Git, and you can manage it just the way you're managing Terraform infrastructure. But it lets you can set the guardrails. So in this case, is an example of a Sentinel code that tells you that you can restrict your VM to a certain size so that you don't over provision. It also works with cost estimation. Terraform Cloud has a cost estimation feature. So every time you provision something, it's going to figure out how much it's going to cost. And then in the governance, you can write some rules saying that, hey, if it's more than $1,000 or $2,000, you would need a kind of a permission or approval workflow for it to proceed. From here, I'm going to hand off to Matt, who's going to show the integration of this governance piece with Bridgecrew's product. Oh, I forgot. If you want to create a free account, go to www.terraform.io/cloud or the thing. But Matt's going to show how Terraform Cloud and Bridgecrew work together, how they can collaborate, and how Bridgecrew makes it easier to develop these guardrails for your organization.
Yeah, exactly. And I was muted there, Prakash, before you went on to the guardrails, but just on the Terraform Cloud side of things, all of those attendees that are familiar with Terraform, you always end up with the same questions. You end up with well, okay, like if I'm running it locally, where do I save my plan files? And how do I deal with kind of people committing those plan files into Git because they contain sensitive information, but at the same time, I need to put them somewhere so that someone else can take on the same state and do a deploy. So you end up having to work out some kind of automation around putting your plan files somewhere. If that automation is then not on a local machine, you're dealing with keys and you're dealing with secrets. And so, yeah, Terraform Cloud really does just deal with all of those things that at some point, like everyone that has done open source Terraform is going to hit.
Right.
And I've certainly enjoyed kind of using that workflow and obviously the APIs and the extensibility there throughout kind of working on these workshops. So yeah, and the second thing I'd kind of say is, much like Bridgecrew sign up, I absolutely love that both of the things we're doing today have free versions that you can just sign up and get a demo account or get the free version. And everything we're doing today on the Bridgecrew side and on the Terraform Cloud side is in those kind of free instant to sign up accounts. So, for me, that's a must in the kind of DevOps world. I don't want to be told what something can do. I want to go and touch it and use it and play with it and kind of understand how it will fit into my workflow. So everything we're going to cover today is repeatable by anyone on this webinar. So please do go and give this a try. We'd love to get feedback. We'd love to kind of hear from you on our Slack or on Twitter. Thoughts, ideas, what you're doing with it. So yeah, just just really cool that kind of all this is repeatable and nice and easy to set up.
Right.
And then talking about the kind of Bridgecrew integration, and we'll touch on this as we kind of dive into the demos. But the way this works is that the guardrails, the Sentinel part of Terraform Cloud is pluggable. And because Bridgecrew comes with, 500 plus out of the box policies in different categories for different clouds, for different severities, we can basically plug those via the Terraform Cloud Sentinel APIs into any run you are doing in Terraform Cloud to kind of, magically augment those pre-built security policies into Terraform Cloud, and also then allow the security team that may have kind of other policies and other things set up in Bridgecrew to actually kind of see that integration. So we have, developers doing what developers do best, which is using Terraform, deploying, working in the IDE, and then you have that kind of extra information coming back to Bridgecrew to complete that loop and that reporting loop. So we'll show both of those, but just a little bit of background first, making sure they're kind of in the slides for people that want to go back and have a look at this. But as you touched on, Prakash, very simple pieces of Terraform. We have a specific resource, such as an AWS instance or an EC2 instance. We give it a name, and then there are some items that we'll need. So either from variables that we can store centrally, or specifically say, hey, I want this instance type and this availability zone, and things that are related to this cloud, AWS, things that are related to an EC2 instance. And we just really easily describe our infrastructure. And then what Terraform can do is it can connect to our infrastructure via the AWS APIs in this case. When we do a plan, it can look at the current state of the infrastructure in AWS and it go, okay, what changes would I need to make what has just been described to me real? So Terraform Plan allows us to see the changes before they're ever going to happen. And it would say, yeah, we need to add one EC2 instance. And then if we're happy with that, we can do Terraform Apply. And that will actually physically go and make that real in the infrastructure. And while this is all on the CLI, this is everything that Terraform Cloud is kind of automating for you in the background. So that doesn't need to be on an individual's machine. So when it comes to these guardrails, you don't want to be thinking about security. I generally find that developers are in kind of, and this is probably a vast oversimplification, but developers are usually kind of in one of two personas, I find. Either they kind of have a passionate interest in security anyway. Maybe they came from a security team. Maybe they just are interested in kind of pen testing or red teaming or kind of security in general. And so you have that kind of developer on the team who is a developer, but is almost kind of acting as himself a security advocate because he has a passion for, or she has a passion for security in that area. And then you have the alternative developers who know security is a must. It's a business imperative. Things have to be secure. There are guidelines they need to go through, but it's not something that particularly excites them. They don't want security to get in their way. Right. And regardless of which of those personas you are, you're still not going to want to spend days of your life repeatedly checking for the same things manually. So whether you're a security advocate or not, you're going to want this automated. You're going to want this just like your CI/CD checks. You're not going to go and run all those Postman collections yourselves. You're going to, you're going to hopefully have something that just tells you whether there's something wrong.
And also I'd like to add is the complexity of the cloud APIs has become so big, like it's hard for even any one person to know all the security implications of all the configurations that are possible. So you could be an expert on EC2 and this thing, but when you add this new resource or a new thing, you may miss something. It's very easy to. So I think that's why you need something like this that's automated.
100% agree. I often think this myself. Like you look at the number of products available in a single cloud provider nowadays. There is no way anyone is going to remember at the top of their head all the defaults which are secure, all the insecure defaults that need changing, what the like limits are for different products that may or may not affect performance and reliability. It's just too much. So yeah, just having that kind of virtual security assistant constantly kind of just double checking these things in the background is really what we're all about.
Yeah.
So here, for example, is an insecure piece, a little bit more advanced because we've got a few extra options, but we can still see it's just a single resource. This happens to be an Azure Kubernetes cluster, rather, excitedly called Kate's cluster. And we can see here that we have a couple of things which would be considered bad security posture. So the Kubernetes dashboard is enabled, and role-based access control is disabled. And there may be a load of other things when we think about a Kubernetes cluster that may need checking. So is there a network policy configured to make sure people can't hit our insecured Kubernetes endpoints on the same VPC or on the same network? Is there, again, restrictions on who can access the API server, rather than just relying on the actual authentication, just like you wouldn't leave your SSH server open to the wild. You'd have a bastion, or which could only be accessed via certain IP addresses, and is logging enabled so that you can actually have a record of what happened if and when you need to go and explore. So all those kind of things, that's 5 things that would have to checked manually. There, for example, some of the guardrails that we want to be able to automatically help your teams with as just part of the Terraform plan and apply process that you're going to automate anyway. So we just want to be that kind of plug-in security helper. And then to kind of make it easier to experiment and to play with this, we appreciate that it's very hard to, my apologies, it's very hard to jump into new technologies using kind of your actual code repos. No one's going to go, sweet, I'll just fork production and use that to kind of test out some new tools that I'm not familiar with. And so because of that, we've created the GOAT projects. And the GOAT projects are a collection of, and this is where we all get very excited because I can actually jump out of slides. The GOAT projects are a collection of purposely vulnerable repos. So they're designed as infrastructure as code repos. There's one for CloudFormation, and the one we'll be playing with today is called TerraGoat. This repo lives at Bridgecrew /TerraGoat, and this is purposely vulnerable Terraform. So within here, you will find a Terraform directory with AWS, Azure, GCP, and in here is literally the worst, most insecure default set of Terraform we could try to write. So for example, if we look in IAM, you will find all kinds of IAM policies which allow everyone do everything on any resource with no principal protection or anything like that. If we go into, so for example, EC2, we'll find secret keys accidentally left in user data for an EC2 instance. We'll find security groups which are completely wide open to the world, and just all kinds of things that you probably do not want making it to production. So these are really good projects to use to kind of get familiar with infrastructure as code security, to look at some of the defaults and some of the guardrails that Prakash was talking about installing, and to kind of just prove to yourself that you can build an automated pipeline that allows you to catch these things before they get into production. And so without further ado, let's have a look at that. So if we jump magically over to Terraform Cloud, I'm in Terraform Cloud. In a new workspace we set up for this environment. And as you can see, I've got 2 workspaces, and they're pointed to 2 different repos. And one of the repos, and the first one we're going to look at, is what we've just talked about. We've created a new Terraform Cloud workspace called Bridgecrew Webinar Feb 17, and it's pointed at my fork of TerraGoat. And so what we're going to look at here is we're just going to plan as if we have some changes. So we are going to do a webinar hello world, and we're going to queue that plan. And what this is going to do is this is going to centrally automate within Terraform Cloud the Terraform plan, the cost estimation, the guardrails that Prakash talked about, and we can see that going here. And we can see it's going to try and create all these insecure resources from the AWS section of TerraGo. And we do that actually because it's all in one repo, within the Terraform Cloud, we can actually set the working directory. So that's why it's just pulling the AWS resources for this demo. So if we go and have a look at that current run, and you can see to the point made earlier, we keep all the previous state and all the Terraform plan files and things like that. So if we go into the current run, we can see the planning finished. It was going to create a load of new resources, I'm sure. Let's have a look at what they were. 52 new insecure resources. It did some cost estimation. And then we failed to deploy. And that's a good thing, because before we apply any of this infrastructure, Bridgecrew's integration has stepped in and has kind of said, hey, for all of these reasons, this is not a good thing to deploy to production. So for example, your Kubernetes cluster does not have secret encryption enabled. Your Kubernetes cluster, just like we saw in the Azure example in the slides, is available to the whole world without any security groups. Your cluster has a public endpoint. Let's find some non-Kubernetes things. Here we go. You have no tags to say who owns what within your environment. You have a security group that is allowing, again, everyone on the world to access port 22 via IPv4. You have content in S3 buckets, which isn't encrypted at rest. So lots and lots of reasons that this probably isn't infrastructure you want to deploy. And at this point, because I've set this integration up as a soft fail, we can override it with a message, or we can discard that run and say, that's a bad idea. And so this is kind of the guardrails that we were talking about there. Can everyone still see the hello world? How's that looking, Prakash?
Yeah, we can see that.
Perfect. And obviously every single thing in that policy soft check fail kind of highlights really what Bridgecrew is all about and why this is a really exciting integration with Terraform Cloud, because a developer is going to be in this environment. This is their workflow. They're going to be deploying, via Terraform Cloud in this scenario, and they don't necessarily want to have to leave Terraform Cloud to kind of see anything else. They get all the information they kind of need with some simple explanations. If it's someone seasoned in writing Terraform, they or kind of familiar with having guardrails in place, these will immediately be useful and potentially allow them to just go and quickly make a change. However, we are all about, being that virtual security assistant. And so for that reason, we also provide more details. And not only are we providing these guardrails into Terraform Cloud, but we're also providing this link to our Bridgecrew dashboard, where we are going to be able to see all of those failures annotated to kind of give a lot more information, a lot more context for people that maybe want to deep dive and kind of research into those issues we flagged up. So if we look here, we've kind of followed a direct link. And this is part of the dashboard called code reviews. So what we have is a code review section. So for everything integrated, so all your Terraform Cloud integrations, we can actually see every time Terraform Cloud does a run that uses those guardrails, we actually have the information here. So you can kind of go back and historically look at the security posture of those runs. And there were quite a lot of them, so it's just going to pull that up. Can everyone see run 2 failed in Bridgecrew Cloud? Perfect. Yep. Okay, so what we have here is we're acting on the plan. So obviously Terraform's gone and done a Terraform plan, and we are acting on the plan to look at what's actually going to be deployed into AWS in this case, to decide on some security issues. And as you can see, everything that is kind of mentioned in line in the Terraform Cloud output, the relevant section of the plan file is available with the same issues. And then Sorry, go for it.
Sorry, Matt. So you see an error in Terraform Cloud. You see the violation ID, and that correlates to this message on the bottom. And then this is the part of the plan that you think that's targeting.
That's correct. Yeah, and we can actually drill down into this. So, so there's a couple of things here I wanted to highlight. So just on that whole, not everyone is a security advocate. Not everyone kind of has a security background. By providing this more link here, we provide like this thing we called full guidelines. And so for each of these, and these will match up to the security violation IDs that you saw in Terraform Cloud, we actually provide kind of a overview description, some background information, how you'd manually fix this if it was in production already. And we try and just provide some context for each and every policy we have, just to help people kind of do their own research and kind of understand a little more about the issues they're seeing, rather than just seeing a kind of meaningless security ID, which might not make any sense to them if it's a new technology or if it's something that they're using for the first time. So not only do we have these, but also in the incident screen, we can actually drill down to resource by resource. And the way we do
the resources in the Terraform configuration.
Right. Yeah, exactly. Okay. And so if we head over to incidents, demo gods are not with me today, are they? I've put quite a few filters on my incident screen from a load of other information, which might be giving us the holdup. Let's just try that again. There we go. Oh, typical. There we go. So yeah, we'll just give that incident screen a second. And what we're going to see here is just a way to drill down on a security ID by security ID scenario. So
in this case, I can say that if I need some kind of ISO, certain standard, I can filter it just those security policies. Okay.
Yeah, exactly. So in here in the filter section, so if you were, the code review is really designed as like an at-a-glance developer view of the sections of code that we were focusing on, just to try and help provide a little bit more at a glance from the CLI output. And regardless of the CLI output integration, be it Terraform Cloud, or be it, you're running the Bridgecrew CLI maybe as a local developer's laptop, those code reviews are designed to kind of be like an expanded view of that with those kind of guidelines embedded and things like that. If you then want to dig down into the specifics and filter, almost kind of more as someone on the team that's responsible for fixing these issues, or kind of, digging down from a security investigation standpoint, incidents are really where you want to be. And yeah, we have a massive set of filters here, not only by category, and severity, but also, like you said, by different benchmarks and different parts of your cloud. So is it monitoring related? Is it network related? And also source type. So the more things you integrate with, the environment, the more we're going to see here. So if you integrate runtime so that you can scan AWS issues, we'll see them here under sources as well. So I'm going to save right now. I just want that.
So this one is a list of all the instances that are available, and you can manually make your own as well over here, or is that a different piece?
Yeah, I'll show custom policies in a moment. So by default, what we're seeing here is all of the built-in Bridgecrew policies that we have triggered within that TerraGoat repo that we've scanned. So in here, we will see things like, you'll recognize some of these from when we were scrolling through. What I'm going to do, because we care about AWS, we can just search for things, and you'll see all the Bridgecrew kind of security violations IDs. They're pretty sensibly named, kind of, Bridgecrew, cloud type, and then, the subtopic, general monitoring, IAM, et cetera, et cetera, et cetera. So we'll save that as a default filter. And what we will see here are things that are very familiar from the output. So ensure no hard-coded secrets in Lambda environment, for example. And if we click on that, we'll actually see the piece of Terraform within TerraGoat, which is causing us the issue. So we can see this resource is an AWS Lambda function. The environment has variables which look like AWS secret keys. That's probably not a good thing. Ensure all data stored in S3 buckets is securely encrypted at rest. And you can see here, this is what I'm saying about the drill down. So this is one security violation, but it covers multiple different objects within the Terraform. So for each one, we can actually see what we're talking about. And for things that are kind of a binary decision, so for example, what do I mean by that? If your Terraform has no tags, right? No owner ID, no blah, blah, blah. Every company's policy for tagging cloud resources is going to be different. Bridgecrew or HashiCorp can't really mandate a tagging policy because it might not fit the organization's need. Whereas something like server-side encryption being turned on, that's very binary. It's either turned on for S3 buckets by default or it isn't. So for things that are kind of binary like that and don't require organizational decisions, we actually here, when you kind of drill down into it, actually provide a diff, as in this would fix this security violation. And what we can do on those issues is we can actually just tick these issues that we want remediated. Where's it gone?
So Matt, can it also figure out if it's in a variable? Let's say the AES 256, if it was a variable, would that still be able to figure that out?
So from the plan file, we do get kind of variables rendered from the cloud, which is why it's really cool that through the Terraform Cloud integration, we can scan the plan file, because sometimes we're going to get information there that we didn't have from the Terraform itself. When we come to automatic fixes, because as you'll see here, this fix, it wouldn't be right to try and somehow push this fix back into that CI/CD run, because the CI/CD run is immutable. Once it's happened, it's happened. The place we should be fixing these things is in the original source code repository, where we have versions and tracking and commits. So you'll see here, for example, these data not encrypted at rest. I've ticked 3 at once, and I've clicked the fix button, and we can say, yep, 3 resources in the MetaHertz TerraGoat repo. Let's automatically fix those. And what that's going to go and do is it's going to automatically raise me a pull request in my source of truth, in my code repo.
Okay.
So there we go. We see success. And if I go into here and look at pull requests, you can see just now a Bridgecrew fix for S3 bucket configuration. Again, keeping everything as close to the developer workflow as possible. We provide developers information that this has come from Bridgecrew. Details and guidelines go straight to those guidelines I showed you. Detail goes back to the incidents with a filter for just the particular issue we're looking at here. And what we can see in the file changes is we're basically saying that for those S3 buckets, and because this has been used variables and loops, every single one of them is using this particular environment setup. So we're just going to enable versioning in there. So what and you can see that for things that are only available in the plan, we're not necessarily going to be able to offer an automated fix for those, because that'll only be resolved in the plan, because it's depending on things being pulled from that particular cloud provider's account. However, for things that we know we can safely fix hands-free in the Terraform itself, we'll provide these automated fixes. And for everything else, we'll still provide the incident list, the drill down of the individual resources. We'll show you the bit of Terraform that we're talking about. But for example, tagging or variables, we're just going to say, this is an issue, but you need a discussion with your team to fix it.
So when it does the pull request, does a speculative plan happen to kind of validate that?
So at the moment, there's no integration between, obviously what we do have here is.
So it does do that, yeah.
We've got everything that at this point, this isn't coming from Bridgecrew. This is just the fact that we have this repo integrated with Terraform Cloud. So we are not, as Bridgecrew, going to kind of go and kick off any CI/CD run. But the kind people with you guys at HashiCorp have done for us. And yeah, we see that automatically going, this is a new PR. We're scanning the PR as if it's a branch. And what you will see in here is that for this run, which is number 4, obviously because it's TerraGoat, there are a lot of vulnerabilities. But for this new run, which also gets put into the code review screen, because every run that happens for the guardrails, we log in here, you'll see there will be less errors than on the previous run.
Right.
Because we've fixed some of those in that speculative issue. So 41 resources, 38 errors found. And if we go back to code reviews and look at this one, errors found. We'll see if it disappears from violations. I'm pretty sure we will see 2 less issues in the output. Hang on a sec.
That is pretty cool how Bridgecrew is like suggesting the code change. I would like to see the source code for that sometime.
Yeah, that's
pretty neat.
That is some logic that I wish I fully understood. I'll be honest. We got Barak and his team of engineers to thank for that. S316.
Hey, there's a question that might be appropriate to answer here from Ashish Goel. He's asking, does pull request raised as a result of fix provides auditability in terms of who triggered the fix action, etc.? And I think the Bridgecrew is the user in this case, right? Bridgecrew is acting as a developer and doing that fix.
Yes. So 2 integrations are needed to enable this from the Bridgecrew side. Again, both available in our kind of developer and free editions. So the 2 integrations we need, and they all come from the integrations page, is the Terraform Cloud integration, which provides you, and you can see I've got a couple of different workspaces set up. You provide your workspace ID, workspace name, your Terraform Cloud API token, and then it creates you a policy to paste into Terraform Cloud, which is effectively how the integration for the guardrails works back and forth to there. And then also to do the kind of fix workflow that we've just seen and to kind of do that GitHub integration so we can annotate that PR and add comments as a bot. There's also the GitHub integration, which you can see I've given access to my TerraGoat repo. So yeah, it will show up as the Bridgecrew bot. You'll see here for the pull request, but obviously then to make that pull request real, I have far too many tabs open for my own good. Let me just click there again. To make that pull request real, obviously, the pull request isn't endangering your infrastructure. That's only, or fixing your infrastructure in this case, that only happens when you're happy with the tests and you go, yeah, merge pull request. And then obviously, I, as a real person, am confirming that merge. So at that point, that will obviously trigger a change to main or whichever branch you're committing to, which will in itself trigger a run as me, because I am the person that allowed that code change to get into main.
So another question that came up was you are demonstrating AWS. What other providers do you support out of the box? Is the question Azure? Is Azure supported as well?
Yeah, so a great way to kind of think about what's provided is to either sign up and look at our integrations page. The short answer is yes. We support integrations with AWS, GCP, and Azure as clouds. We support any Kubernetes cluster to report on its current workloads and scan the Kubernetes manifests of those workloads to look for Kubernetes issues, multiple source control, and multiple different CI pipelines as well. And then in terms of outputs, Slack, Jira, Splunk, the usual. If you want to send information when we find a new incident, when there is a new failed code build from one of these integrations, we can send those out to multiple places. And also for those of you that like pretty graphics, we have a little pretty dashboard as well.
So let's say there's a provider that's not there. Can you write your own policies and then for those providers?
I am glad you asked. So one of the things you won't have maybe noticed when we were looking at this incidents view before is something called allowed images. And it's basically flagging up two critical violations here that in the TerraGoat repo, I have, and I can again click through to have a look at these and find the piece of Terraform that I care about. I'm setting up a AWS instance, an EC2 VM, and I'm using this AMI. So AWS AMI, Amazon Linux 2. I'm not sure what the other one is, but you can see what I mean. And the reason this is flagging up as an issue, what's wrong with number 2, is I've actually written a custom policy to complement maybe for my own organizational security practices, or just something that isn't covered by one of our out-of-the-box policies. I've actually created, as you can see, so created by all of these are Bridgecrew. But I have created this one custom policy called allowed images. And what I've basically said in here, and this is a full web-based editor, which not only allows you to live see which things will or won't be caught by it, so you can actually kind of test your policy live as you go. In fact, let's actually kind of look at that. Let's take, that's a variable. You can take any Terraform object, and we actually, as you'll see in here, so I've given it a name, allowed images. I've given it a category for our security categories. If I wanted to tie it to a specific benchmark, I could, but I haven't in this case. And in resource definition, I'm saying that for AWS, I want to check something that relates to EC2 images. And then in definition, you'll see that we are dynamically pulling every Terraform object related to a AWS instance that you can then do binary or string operations on. So in my case, I am basically saying I only want people to spin up instances of a VM with an AMI of test AMI. And if you're not using test AMI, I want to highlight that as a violation.
That's pretty cool.
Cool. Yeah, and we have a lot of plans for this policy editor. We're going to allow you to view this policy editor as code and import and export them as well as just the kind of UI as well. I'm well aware that because of the screen sharing issue, we're running out of a little bit of time here. Prakash, is there anything kind of you wanted to add before I kind of close up with drift detection?
I think this is good. Yeah, we are running short of time. So yeah, let's move to that. And then we can catch some of the questions.
Sounds great. Yeah. And, any questions afterwards, we're at Bridgecrew IO. Prakash, if you want to offer your Twitter or the best way to people to get hold of you for follow-up conversations.
Yeah, I'll drop it on the chat.
That's absolutely perfect. Okay. Yeah. By all means, ping either of us. And we can carry on any conversations. So the last thing I wanted to show again is another integration, and it ties into what we've just seen with Terraform Cloud, is our AWS read-only integration. And what's really cool about this is we can basically integrate directly with our AWS account, and we create here automatically using CloudFormation a very small amount. The demo gods are not with me here today, are they? We create an absolutely minimal security access, so read only, as little as possible connection from the Bridgecrew cloud to your AWS account. And what that allows us to do is that allows us to compare the Terraform plans. And by default, twice a day, we do this and then send alerts if something doesn't match. But if you're doing your own customizations, you can also take a look at our really cool new APIs, which allow you to automatically trigger a scan, for example, or kind of list fixes, policies, and suppressions in a programmatic way, so you can integrate with your own custom pipelines. But what we basically allow here is an automated way to take the latest plan file that we got from Terraform Cloud, and to compare that plan file going forward to what we're actually seeing in AWS. And then if that doesn't match, what we do is we generate what we call a drift detection. And we have a blog post on drift detection with screenshots and things, because I am not going to be able to reconnect my AWS account because I've been jumping between them. Apologies for that. I'm not going to be able to connect this in time. But what basically happens is once we have this integration here for AWS, we start taking all of our default policies and actually checking them against real objects running in your AWS environment or your Azure or your GCP, so that we can say, hey, not only is this not meant to go from Terraform into production because it's insecure, but also these things already running in your AWS accounts need attention. And we also support dynamic real-time fixes if necessary for some of those as well. And again, if something changes that is in Terraform that was deployed as, for example, one size of AWS instance, and someone goes in and manually changes a security group and manually changes an instance type, we'll notice that as a drift. And within incidents, there's a filter type for drifts, where you can basically say, yeah, that shouldn't have happened. And yeah, without carrying on there over time, do we have any questions that we can see? Let's have a quick look. We've got one in Q&A. Yes,
we answered the question, and I think that's all the time we have. Again, please feel free to reach out on Slack or to our handles. Matt, if you want to drop yours in the chat, go for it.
Yeah, I certainly will here.
And the winner of the raffle is in the chat as well. Congratulations. Thanks everyone for joining, and we'll talk to you again soon.